All right, I'm going to actually skip to a moment to go to the back page. Many of you have been struggling with how do I find lateral area, surface area, and volume of prisms and pyramids. Remember, first of all, the key is the base. And I don't mean the base is just a side. The base is the defined part where you have that on a prism it's the two congruent to polygon sides that normally aren't rectangles that are going to work. Or on like pyramids, it's the bottom of the pyramid. That's your base. How do I find lateral area, surface area, volume? And I promise if you go through these steps, you're more likely to get the correct answer. So here's the first thing you always have to do. Number one, draw the base. And that means if it's a square, you draw the square. If it's a triangle, you draw the triangle. If you have a hexagon, you draw the hexagon. If it's a pentagon, you draw the pentagon. I don't care what it is, but a lot of times it is introduced to you. The second thing you do is you find the perimeter and area. So capital P here, and area of the base. And that's the capital B. You do those yet. You show the formulas, you show your work, you calculate them. Then, number 3, you write your formulas, and then plug it in, put in your values and chug out your answer, okay? Plug and chug. And finally, label correctly. If you do this part, you will be fine. Sometimes you have to do a little bit more in there, but this is the basic approach to solving for prisms and pyramids. And if you do this process, you'll be fine. If you don't do this process, I don't really get upset if you sink yourself, because that means you're not doing what you've been taught. So let's look at this next one. It says find the lateral area and surface area of a regular square pyramid with base edge length 14 centimeters and a slant height of 25 centimeters. So I know my slant height is 25. And what's my base? Because the first thing I'm supposed to do is draw my base. It's a square pyramid. So my base, I draw a square. And it's not hard to show that. And it says they're 14 centimeters. All right, I got my 14, 14, and 14. So what are we supposed to do next? On the previous page, it said to do the P and B. Find the perimeter. Well, that's 4 times 14. Well, that's 56. The second thing I tell you is to find the area of the base. So that's base times height. 14 times 14 is 196. All right. Now, this would be in centimeters. This would be in square centimeters. But the cool thing is I don't need to really worry about the label yet until I plug it in. Well, it's always better to find your lateral area first. So on this one, I got 1/2 the perimeter of the base times the slant height. So I get 1/2 of 56 times 25. Well, 28 times 25 is 700 square centimeters. So that's your lateral area. Well, your surface area is just your lateral area plus the area of the base. And I know some of you prefer probably writing it like this. That is totally fine. The reason why I asked you to do this is trying to keep the process in your head what you're doing. But we can plug in our lateral area and then just put in our base. Well, it's 896 square centimeters because we're looking for area. See, it's not hard to do if you draw the base. Now on the next one it says find the lateral area and surface area of the regular pyramid. Well, notice where that's pointing. That's coming down the surface of my pyramid. So my slant height is 16. My base edge is 10. What type of base is on here? That's right. It's a hexagon. So what's the first thing I'm going to ask you to do? Draw your base, right? I know that's 10 inches. All right, and I know they're all the same size. Okay, so what's the first thing I always want you to do? Find the perimeter. So I have 6 sides, so 6 times 10 is 60 inches. What's the next thing I ask you to do? Find the area of the base. Well, if you don't know this formula, you don't know how to do this. Did everyone just hear me on that? I'm pretty I get a little frustrated when I say make sure you review so you know. Well, this is a regular based pyramid. Regular pyramids have to have regular bases. Well, this is a hexagon and have to be a regular polygon. So it's 1/2 apothem times perimeter. So guess what I'm going to do? Draw in my central angle triangle. There's my apothem. Oh, look. It bisects the base. So that segment right there is 5 inches. I have to find my central angle triangle. My central angle, oh, and then I find the central angle after that. Oh, that's 60, but it bisects that, so that's 30 and 60. And I realize, oh, this is the short leg of a 30, 60, 90 triangle. To get to the long leg, I multiply by √3. So I get 5 √3. Now I have all the information I need to solve for the area of the base. It's 1/2 of 5 √3 times 60. So half of 60 is 30. 30 times 5 is 150 √3 square inches. Now I can do lateral area, and now I can do my surface area. Lateral area, 1/2 the perimeter of the base times slant height. I don't know, I felt like singing that because I get bored doing this videos, just talking to myself. So I get 1/2 the perimeter, which is 60. Your slant height is going to be 16. So 1/2 of 60 is 30. Times 16, you're going to get 480 square inches. So then when I do my surface area, I know it's my lateral area. All right, 1/2 perimeter of the base times the slant height plus the area of the base. I only have one base, it's just the bottom part. So I get 480 plus 150 √3. Now notice I didn't tell you nearest tenth, nearest whole number, anything like that, so therefore you must leave it in exact form. Alright, now I'm going to actually do a pretty complicated problem, but there's a lot of different things that you have in order to do this one. So when I look at this, and I'm asked to do the following, it says find the lateral area and surface area of a regular triangular pyramid. So what type of base must I have? The base, that's right, is going to be an equilateral triangle. All the sides are the same. If all the sides are the same, what do I know about the height? That's right. The height is going to bisect it. And we know this would be 3 and 3. But also if it's equilateral, it's also equiangular. And so all the big angles are 60 degrees. So I actually use, again, a 30, 60, 90 triangle to help me solve for it. So let's do the perimeter first. Actually, we'll do the perimeter over here. The perimeter is going to be 3 times 6, which is 18. The area of the base is 1/2 base times height, because it's a triangle. Well, the base of the triangle is the whole side length, so that's 6. The height of it, oh, I have to figure out the height. It's the short leg times the times √3 to get the long leg, so that's 3 √3. So that's going to be 3 √3 here. And so I get 9 √3 is the area of my base. But now we have a problem. Notice they gave us the lateral edge, not the slant height. So how in the world am I going to be able to work with this? Well, you draw the lateral face this time. Okay? And the lateral face is an isosceles triangle. The bottom is the base edge. The lateral edge is 3 √10, but I want the slant height. Well, what do you think the slant height's going to do to the base edge? That's right, bisects it. Now I can use the Pythagorean theorem to solve for what's missing. So I go over here and I go slant height squared plus 3 squared equals 3 times the square root of 10 squared. So slant height squared plus 9 equals 90. So 3 √10 squared is 90. Subtract 9. Your slant height squared is 81. You take the square root of both sides. Your slant height is equal to 9. Now I have everything I need to find the perimeter, the perimeter actually we already did, excuse me, lateral area and surface area. I'm really tired today. I even got a lot of sleep last night. The lateral area is 1/2 the perimeter times the slant height, so it's 1/2 of 18 times 9. So we end up getting, what did we get? That's right, 81. And it's square feet. Our surface area is just our lateral area plus the area of the base. So we get 81 plus the area of the base, which is 9√3. And since we didn't ask for it to be in decimal or anything like that, we're just going to leave it in this form. Please do not add those. Those are not alike terms. And that would be your surface area. All right, we're going to do one more example, and actually an example from the book on the next slide. So hopefully it will help us out just a little bit.